Okay, we are live. Hello, everyone, and sorry for the short delay. We had some technical issues in the backstage regarding the presentation. Um, Luckily, there is a Jonathan with me here, and he will help me to give the presentation. So, without further ado, we can start. And thank you, Jonathan. So last week we had a webinar where we talked about OAuth2 authentication. What is it? How it works? But we touched only tip of the iceberg regarding how it works in the background. We talked a little bit about the tokens, and we had lots of questions regarding tokens itself, which was a little bit surprising, but it's understandable. So in order to work with OAuth2, you need to understand the tokens. So what we are trying to do today, we are going to focus only on the tokens. I intentionally not mentioning GWT tokens because they are not the only type of the tokens that we are going to talk about. So hopefully at the end of this webinar, you will have good understanding about the tokens, what they are, their lifetimes, how you can use them to secure your applications, to secure your APIs, and what are the scopes and all the strategies that you can use to enhance the security. We will have part 3 of the webinar where we are going to focus on OAuth clients. And a colleague of mine from Serverless Guru, Mersat, will join me, and we will show you how to register applications, which are basically OAuth clients, how to secure them. You will see different examples with different grants. You will see single page applications, IoT, but I don't want to spoil that. I'm going to focus on the tokens in this webinar. So let's get started. So as usual, if you don't know who we are Serverless Guru. We are your reliable partner. If you will love to talk about serverless, so you can follow us on the social networks. You can find us on serverlessguru.com. You can reach us out and ask everything. We even have a Slack channel for our community where you can ask different questions. We would be happy to talk to you about everything serverless related. And then about me, my name is Almir. I'm a principal developer at Serverless Guru. I have more than 20 years of experience in the IT, working on different areas. And one of the areas, one of my focus areas is application security. And this is why I'm really happy to talk about this topic today. So let's get started with our agenda today. We had a little bit of introduction of what this webinar is all about, and we are going to talk a little bit about the token-based authentication, just to remind ourselves on the first webinar, because this is important for what is coming next. We are going to deep dive into the reference and the self-encoded tokens, what they are, how can you use it, what's the purpose of it, which one is better for you, and then we're going to deep dive into the JWT tokens. We are going to talk about the anatomy, decoding. We're going to talk about claims, lifetimes, validation. And if this sounds really unfamiliar to you, you will find out it's not that complicated, but it is really important to understand, because this is the concept that is really important to understand when it comes to security. Then what happens when token expires, how that looks like from a client side, how that looks from the server side. Can client actually know, or can server actually know when the token expired? How can you get those information? And then we are going to demystify the access tokens, refresh tokens, ID tokens. So it's it's everything about the tokens here. And at the end of this presentation, I will talk a little bit about the scopes, but I will actually show you an example of scopes on GitHub. I will show you some stuff regarding these scopes on the Okta OAuth2, and what they are, what the scope actually is, how you can use it, and then I will actually show what they are not, and what's next if you want to, if you need fine-grained permissions for your application. But we will get there. After that, you will be able to ask questions if there are any, obviously, and if you have some questions during the presentation, I would try to answer those. So let's go with the token-based authentication. So this is just a quick reminder of what we talked about. What we talked about in the first webinar. We talked about session-based authentication, and more important for us this time is the token-based authentication. So as simple as it is, you literally have a client which sends some credentials to the authorization server. So you are exchanging those credentials to get something in return. What you get in return is, in our case, in this type of authentication, is a token. So you get that token, and then you are sending that token to resource server. So we talked about the difference between authorization and resource server. So authorization server is an OAuth server, where you will send your credential, which will validate your credentials, give you the token, issue a token, and then with that token you will go to the resource server, and resource server can be anything, but in this case, let's say that's the API server that is hosting your APIs. So with that token in your header, in your request header, you will send your token, and you will issue request, and you will get the response from the server, if of course your token is valid, and we will get there. So let's get started with the token types. We mentioned before, but now let's just recall what we talked about earlier. So there are two types of tokens. There are reference tokens and self-encoded tokens. So reference tokens, as the name, or some call them I can't opaque. I can't pronounce this word, but opaque tokens. I will try to do it. Are the tokens that actually doesn't contain any information. So when server issue this token, you only have random alphanumeric string, and in order to validate those tokens, server needs to know about it. They need to be stored somewhere, and usually that's some kind of database. It doesn't have to be persistent database. It can be like in memory. It can be like Redis, for example, memcache, where you can create these tokens. So one may ask, why would you use reference tokens? So they don't on its own, they don't mean anything. It's just a random string, unique random string. And why would you use that? So if you don't want your client, either application or user, to know what are the claims within those tokens are, then you will use this token. It's like it's similar to encryption. This is not encryption. This is just a random string, but it is a similar concept. You have this token. You sign your request with this token, and server needs to go to some kind of database, make a query, get me this record with the ID, with primary key, which is this token. And now I have the claim, so I know who this user is. I might have a different information. I might have some personal information like first name, last name, address, email. I also might have scopes, which we will talk about later. And I might have some information like when this token expires. So if I don't find this token in the database, your request is invalid. So you will get 403 from the server. I say, okay, you're unauthorized. You don't have access. Or if if token is there but it is expired, then again you are unauthorized because token has expired. So this is kind of a use case for the opaque tokens, tokens where you can, or reference tokens, where you want to hide information from the clients. So different type of token is actually not JWT, sorry, self-encoded tokens. So self-encoded tokens actually contains some information within the token. So that means that those tokens are encoded, not encrypted. They are encoded, and that means that they can be decoded by the application. And when you decode that token, you will get some information. And the most famous representative of this self-encoded tokens is actually JWT token, which we can see in the next slide. So these tokens actually contains some information. So Rufus, reference means random, self means encoded. No. Self-encoded means that tokens are signed by some algorithm. So first, encode is silly as it is, but let's mention this difference. You probably all know this, but just for the context, encoding and encryption are two different things. So encoding is actually about the data usage and transformation, and encryption is about hiding and securing the information. So when it comes to encryption, you have the plain text, and you encrypt, you transform that text into some unreadable string, something that is completely unreadable, where what doesn't have anything with the original text. And if you have the key, you can decrypt that and return it back into the plain text. So this is the way how you can secure information. So you encrypt it, you send it, and then you decrypt it at the destination. So to make sure that, for example, in transit nobody can read it, or you can keep it somewhere, and if somebody wants to read it, it can't unless it has key to decrypt it, to make it into the to make it back into the transform it back into the original state, into the plain text, which is readable information. While encoding is a different thing. It is just transforming the data from one shape into the another. It's not encryption. It's not hiding information. It's about data usage. So what it is actually. So for example, if you have like query parameters in your in your URL, and inside of that URL you have some special characters which are not URL friendly, you will encode it into some shape which is acceptable by query param, so you don't break URL. For example, you will encrypt it, you will encode it into the base 64. But if you know which encoding is used, you can easily return it back into the original shape. Another example is for sending binary data over the internet. So you will transform it into the text, and then you will transform text back into the binary. So it's just the data transformation. It's not encrypting. So self-encoded tokens are actually encoded data. So JWT token is JSON Web Token. This means that the data that is encoded within this token is actually a JSON document, and the properties that are inside of this token are called claims. So JWT token is signed, encoded, but not encrypted. It can be encrypted, but it's not encrypted by default. It's base 64 encoded. So content is visible, but cannot be changed because it is signed. If you try to tamper with this token, it will become invalid. And this is the great this is the great thing about it. So one thing that is good, and we will talk about this a little bit later, actually we're in very short time, but the difference when using JWT tokens and why they are mainly used in OAuth. It's not required. It's not mandatory to use JWT token. You can use reference token, but mostly the JWT token is used. So the difference is that with the reference tokens, you must go to some kind of storage. They are stored somewhere in some kind of database. They can even be stored on S3. Who knows? So it requires storage. You need to find that that reference and you need to read claims, and then you will know what to do. With JWT, you don't need to do that. You can do the local validation. If you have the key, you can validate the token and see that token is valid, and this is called local validation. Or you can do token introspection and do it on the server, but we'll get there. So the thing is that with reference token compared to local, making a request to the database, so making a query to the database and doing the local validation of JWT, you can see performance. You can see performance benefits with that. So let's take a look a little bit into JWT structure, how it is encoded. So I made here a separation with the colors. So JWT has this structure. This is how every JWT token looks like. So the first part is a header, second part is a payload, and the third part is a signature. So the first part, and they are separated by the dots. So you have header dot payload dot signature. So the first part here is actually telling us it's a metadata. It's information about the token. It contains the algorithm which is used to sign this token, and there is a type of token. So we know this token is JWT, and this is the algorithm that is used. Here in this metadata, we can have additional information, so which is a little bit more advanced. But if server can use multiple keys to sign tokens. So if you have multiple keys that are used to sign this token, then token ID will probably be here in this header, so you know which. So the server will know which key to look for when it's trying to verify the signature of this token. So this is base 64 encoded. And just to show you, I will quickly share my screen and give you the example. I will take this header, and just a second. I will take this header. I will go to my terminal. Okay. Hopefully you can see my screen. Do you see my terminal? Okay, there we go. So I will go to node repo just to give you the quick example that this is actually base 64 encoded. So I took that header part, and I know it's base 64, and I will just say convert this to string, and there you go. You get the header information. We have a algorithm and we have the type, and in a very similar fashion, we can do this with the payload. So if I just replace this part here, and put the payload there we go. We have JSON document. So if you have a token, and I will show you how you can get them from the browser somewhere. You can go to website jwt.io, and you can inspect token. You can inspect token for yourself. So back to the presentation view. So what I show you in the second example was this payload, and this is actually data that you are sending within the token, and this data can be a different. So when in OAuth you have authorization server can send you is sending you access token. And we use analogy with the hotel room in the first webinar. And usually that access token does not contain a lot of information. It contains only necessary information to allow access to something. So we have a hotel card issued on the reception. You go to the room, or you go to the different parts of the hotel, or if you're in some office building, you can go with your card and present that card to the reader, and you either have access or don't have access, where the card reader is actually API on different doors, and your card is actually token. So in that access, so on that card, there is no information about you, who you are. There is just some kind of reference, maybe ID, maybe something, and this is exactly what access tokens are having encoded within within its claims. And we talk about the OpenID Connect, which is extension to the OAuth, which is often used together. And then there is a different type of token, which is the ID token. So access token can be JWT, but it doesn't need to have all the information. So the claims, and those are actually the properties of this JSON document that you have within payload, are the information that you want to send to the client, and that you want to have encoded inside. So be aware that these information are not encrypted. So when you are sending information within the token, I just show you in a terminal how you can easily decode token and get this information from it, extract that information. So what do you notice within those claims? You can see that they all have short names. So you can be you are maybe tempted to send everything. Let's say that you are returning ID token, and the ID token can contain information about the user, or usually contains information about user, because that is the ID token, identification token. You might be tempted to send a lot of information inside, but be aware that some HTTP clients or servers will reject request if the header is larger than let's say 8 kilobytes. So if you put lots of claims within your token, then your token can be very large, and then you might have an issue with making requests to the server. That's why all these claims are having very short name. So there are within the specification there are recommended, and within OAuth specification there are recommended claims. They are recommended, but not mandatory. So if we go to sorry, for a JWT specification, so I will share this link here with you, and I will explain what it contains and what are these claims. So JSON Web Token specification contains a recommendation about the JWT claims, and you will find this link in the reference sections, and hopefully you do see it. Okay, you will find this link in the reference section, and you can see it by yourself. I know that nobody reads the specifications usually, but this is really interesting. So we have several types of claims. So first thing is the registered claim names. So these claims are recommended. They are registered in the claims registry, but it doesn't mean that you need to use these claims. They are not mandatory. You can put your claims in your token in whichever format you want and however you want, but you are not following the standard. Obviously, if you want to follow the standard, you should use these claims, and you can see often claims like this in JWT token. So you can see ISS, which is issuer. This identifies the source of this token. So and this is also one of the security things that you want to know. When you look into this issuer, it is used in the token validation. You want to make sure that the token which you have is issued by that authority. Subclaim, this usually identifies user or client who made the request. And in the example that we had, one of the claims within the payload is actually sub. So you can think about this sub, where you usually can find user ID. You can find this in you can also find this very often in within the access token. So audience, this claim is used to define audience for your APIs. So when securing APIs with this token, you don't want maybe you have a different services. Maybe you have modules and let's say that you are selling them separately. You have subscription for I don't know, accounting APIs, and you have a subscription for procurement APIs. Okay, you can do this with scope. You can do this on many different ways. But for the sake of example, we have the same authorization server, but we want to make sure that somebody who is having who has a token, who has authorized for using procurement APIs and has token for the procurement, so that user can actually abuse and use that token to access the accounting APIs. So if we put in our audience and say this token is intended to be used only by procurement APIs, it will be rejected. So there is also expiration time, which is used to understand if token is expired or not. So when you are doing validation, you check this this expiration time, which is Unix time, and you will see is token expired or not when you are verifying this. So these are one more time, these claims are not mandatory, but they are recommended. And there are also two more types of these claims, and these are actually public claims and public claim names and private claim names. So as these are standardized, and if you have a public claim that you want to make a standard, you need to register that within this registry to avoid. And this is a good practice where you can where your where your public claim names can avoid conflict, because nothing is mandatory. You can put whatever you want, but that means also that if you use some claims that are already registered, you are in danger to make a conflict. When you are validating APIs, you can make a conflict. You can have collision between the names. Private claim names are completely random, sort of speaking. So if they are not public registered, and if they are not recommended by the specification, you can use private claims, just as I said. So you can put whatever you want there, and there is no rule, and there is no they are not safe in the sense of collision. So you can put there whatever you want. The most important thing is that you agree with your users that these are the claims that you are using, and that they may make sure that they are aware of the claims of the claim names that you are using. So you just need to coordinate that, and it's perfectly fine to use them. So the next topic that I want to talk about is token validation. I touched this briefly when we started, And how do we do reference token validation? So these reference tokens means nothing. I mean, they are not there is nothing encoded, so they are just random string, which means nothing. So you need to have database, you need to maintain database, and the only way you can validate them is to go make a query somewhere, get the information that you need. All these claims that are encoded within JWT actually are kept in the database, and so and this has some advantages, but it also comes with some downsides. And first obvious one is performance, but this also doesn't scale well, because if you're wondering why wouldn't I use this, because like I have my database, I don't care, why would I use JWT instead? Well, if for a small services, this is perfectly fine, but when you scale your services, when you have multiple services, and when you have single authorization server, uh, the question is, who will have access to this database? So you need to either allow access to database, so it can so you can validate these tokens, or you need to create another set of APIs which will be like which will be used to access and validate these tokens. So this might be a problem with when it comes to scale. So that's why JWT token is good. Now, if you were wondering, so how come that they don't need to be stored? Well, exactly because of this information which are encoded inside. So with OAuth, we have multiple levels of security. So when securing client, we have client registration and all the stuff that we are going to talk about in part 3 of the webinar. But the thing is, when you issue the token, you don't need to store it, because all the information are already within the token. So they can be easily validated. They can be easily validated within the server itself, without reaching out to database. You can do this validation on your own. So you can have on server something every time you get a request and you get this token, this JWT token within your authorization header. You can get that, you can decode that token, and then you can start and go through all the claims that you find within that token. So you will need to validate issuer of the token. You will need to make sure that it didn't expire, and there are many things. So there are many things within the claims that you should check out to make sure that the token is valid. So what is the recommended way to do this local validation is always to use SDK or library provided by the OAuth server, unless you are creating authorization server and you are creating this SDK. But usually if you use Cognito, you can use AWS SDK, Amplify and stuff to validate requests. With the OAuth, there is a full library for JWT, so you don't need to deal with all the crypto hash stuff that you might or might not know. So that is abstracted from you, and it's a good idea just to use library. But the thing is, you are doing local validation. You get the request, and as an example of this, because if you are watching this webinar, you are probably working with AWS cloud. You probably, and since we are serverless guru, there is a point to this. So when you have your API gateway and when you are creating your custom authorizer, this is exactly what we are doing. So we are getting the token, and then we validate token, and if the token is valid, we have some IAM policy that we return, or we return just deny all. Depends of is token valid or not. And There is a downside. There is a downside to this, and that downside is actually that token can be invalidated. So with reference token, you always go to the database, and if it's not present or if it's expired, that's fine. It's you are just not authorized. Token is not valid, and that's all. However, when you issue JWT token, when server issues JWT token, it forgets about it. It doesn't care. It doesn't care about it. It's not stored in the database. It could be, but it's not. And clients can send these requests using these tokens. And even if user close the application, then this token can be used, even if it's log out from the application. So user click on logout, and we log out, and we clean the tokens from the local storage or wherever token are stored locally. If somebody stole this token, it can continue making the request because token is still valid. It's not invalidated. The problem is client cannot invalidate token on its own, and server and client does not have. If token has not expired and if it's not tampered with, then token is still valid, and so that is obviously the problem, and it's a trade-off. So we'll talk about that in the next slide. But just so you know, there is a way to overcome this, which is token introspection, which is similar how reference tokens are validated, where you actually are going to authorization server and asking server, okay, is this token valid? It doesn't matter. It can be valid, but now in the next slide we will talk about the different situations when the token can actually be invalid, and that the client is not aware of that, or the server is not aware of that, and the local token validation is not aware of this situation. So these are a little bit caveats when using JWT tokens, which you need to be aware of. So the problem that I mentioned is so token is valid. Token has not expired. It's used on the client, but token has been invalidated on server, and it can be invalidated for whichever reason. So maybe you have just suspended the user for any reason. You deleted user, you revoked access to something. Maybe user changed password. So it's up to you how you make these rules when the token becomes invalid. But these are some of the situation. Yeah, Rufus, this is exactly. Thank you, Rufus, for the question. So what is the most common reason a token would be invalidated? So these are exactly the cases why it can be invalidated. So imagine. So for one reason that comes to my mind first is like you change the password, and we want to invalidate all your previous logins because you suspect that somebody has your password, and whoever has your password can generate tokens. So we want to change password, and when you change the password, that's not enough. We want to invalidate your tokens. We revoke access to the application. Whatever reason is that, maybe we added some permissions, and the old token is not valid anymore because there are some scopes within that token that prevents you to access something. We want to issue a new token. So those are the common cases. There might be many reasons for that, but the problem now is with the local validation. Local validation checks only, is token expired, is it signed correctly, is it tampered with, is everything okay? But you don't know, is it invalidated, because you only, it's self-contained token. You don't, in this case, in these critical cases, you need to use token introspection. And when do you use this? And this is up to the developer, to architects, how they design the system, when they will use token introspection when they will use local validation. Local validation adds no latency to the APIs. It's the fastest, quickest way to check the token validity. But in these special cases, you are doing token introspection, and you are actually asking server, you are making a network request to, okay, please validate everything. Is this token valid? Is it revoked? Is it for any reason invalidated? Basically, and the server will return, yeah, it's valid or invalid. So there is no third option, maybe valid. That cannot be. So this is similar to reference token. And in the real world scenario, if the token becomes invalid, no, you cannot change the token. Once the token is issued, so when server issues a token cannot be changed. So that's what it is. It's signed that way. It's unique, and it can be decoded. It can be checked. Is it valid? But it cannot be changed. So if you invalidate token for any reason, you will get the new token. So if you need to access again, you will server will reissue another token. So you will not validate that token again, and there is no reason to do so. The best way is to actually issue a new one. So the token introspection is also interesting. So and if you ask yourself why I'm not using this method, why I'm not using always token introspection, because it's slower. It's slower, and it's only needed in special cases, in case you need to really increased level of security, when you want to make sure that that everything is okay, and that the token is valid. So if you are using, and you can combine these two methods. So if you have, for example, let's say if you have API gateway in front of your services, so you can use local validation to make any kind of request. But let's say when it comes to a payment gateway, when it comes to some really critical operations, like you have a shopping cart or a payment gateway, where you need to make sure that actually token is not revoked at some point, then it's okay to add some latency to check that, and you will do the token introspection when you are validating payment, when you are checking that authorization is okay. You will do token introspection. You don't care if in that case a little bit of latency is added, because it's necessary to make sure that that everything is in place, that somebody is not using invalid token. And now, talking about that latency, let's talk a little bit about the token lifetimes. I already mentioned that we have claim within the token that says the expiration time, EXP claim. So expiration time is actually until when this token is valid. So in order to increase security, obviously the best way is to have shorter lifetimes. So what that means? So the best way is okay, I will issue a short living token, like I don't know, 5 minutes, and that's the most secure way. And after 5 minutes, it's invalid, and even if somebody steal this token, I don't care, it's not valid anymore. So yeah, but what is the problem here? User experience. Do you really want to frustrate your users and give them a 5 minutes or 30 minutes long token, and ask them every 5 minutes or every 30 minutes to log into your application? I don't think so. You will most probably lose your user, and nobody is going to use your application, because it's just bad user experience. It's frustrating. So when you are choosing the lifetimes, you need to it's always a trade-off. So when you're choosing lifetimes, you need to take into consideration many different things. So user experience and security. If we are talking about the administration critical, application critical operations where administrators are doing some operations on the server which are potentially dangerous actions, then we probably want to have short-lived tokens in that case, and we are using those for the CI/CD deployments when when we are requesting temporary credentials to access something. But this is okay because these users are administrator users and they're absolutely aware. So these are people like we are who are absolutely aware of what is happening, and they don't mind if they are logged out quickly. So I don't want to leave my computer um, in AWS console in the organization root and with the audit account where I can have access to everything, and then just I leave my desk and my token lasts forever, and so somebody will sit down and can do uh, anything. So we want, even if I was careless, I want to be logged out after certain amount of time. So when it comes to deciding on how long you want your access token to last, you need to take many things into the consideration. So there is no like silver bullet or absolute rule. So this is rule of thumb. This is how you're going to do it. It's really up to you, and it comes down to different implementations. So speaking of those things, we have three common types of tokens which are issued by OAuth server, and you can see those within your application, even if you are using Cognito. First, I will show you our Cloud GTO application, and I will use that one because it is using a Cognito, and I will show you how Cognito issues these tokens, just so you can see it. Hopefully, okay, I will try to share my whole browser. Okay, so hopefully you see this screen, Cloud GTO, and what I'm doing here, I'm inspecting this web page, and I'm here in the local storage of the browser. And what I'm going to do, I'm going to log in to the application, and hopefully, if I just know my password, so let's give it a try. Hopefully, this one will be correct. Okay, there we go. So I'm logged into Cloud GTO, and if we look into the local storage now, you can see ID token here, access token, refresh token. So let's inspect all of them. So let's take first this access token and see what kind of information we can see. So for that, we will use jwt.io website. So I will just paste token here, and let's see what we have. So they also have these nice colors. So this is the header dot payload, which is in purple, and then we have signature. So let's see. First, within the header, we have key ID. So this means that our server is using multiple keys to sign the token. So this is the ID of the key that is used to sign this token, and this is the algorithm used to sign it. Within the payload, we don't know much about the user. We have this sub, which is most probably the user ID within the user pool of the Cognito. We have issuer, and all these claims here within the payload are actually OAuth within OAuth specification, which claims should OAuth server issue for the access tokens. So JTI, this is the token unique ID, which you can use it for different purposes. Expiration time, these are all Unix times, and yeah, I didn't know this, but there is a really nice. So there is a actually conversion to the real time. Expiration time, issued time when the token has been issued, and for what this token is used for the access. So this is the purpose of this token. Authentication time. So when we logged into the server, and yeah, so there on the client ID. So this is the application. This is the application, and this is about this client ID. We are going to talk about in the next webinar. But this is the access token. So we don't have much information about our user. So let's see what else do we have. So we have ID token. Let's see what kind of information is here. It's also JWT token, and okay, I'm also curious what kind of information are here. So let's see. Okay, now within this ID token, there is my email address, and there are some additional information that this email has been verified. And here we can add additional claims if we want to add to our identity. In our case, we are just showing as identification. We are just showing the email in this ID token. And for the refresh token, I'm actually doing this first time, but I don't expect to see any kind of information. I don't even expect it to be JWT token. I expect it to be something. It could be JWT, but I don't think it might be probably encrypted. Yeah. So it's JWT, but it is encrypted. So as you can see, this data, we don't know what is inside of this refresh token. So to stop sharing this screen. Yeah, it's 1, 2, 3. Well, actually, it's 3 to 1. You were close, Jonathan. So and so speaking about these three tokens, so what they are, we talked about access token, what it is. We talked about in previous webinar what ID token is, but okay, access token is just access. You don't know any specific personal identification information about the user. ID token is used for that if you need it, and this goes within. So access token is part of the OAuth. ID token is OpenID Connect, so that is the extension to the OAuth. As you can see, they are used together, like often is the case. And refresh token here is actually so you don't need to type password each time you want to re-authenticate. So what's this? So access token can be set to last for let's say 30 minutes or 1 hour, but refresh token can actually be like 30 days. And when access token expires, actually refresh token will be sent to the server, and you will get the new access token. So this is the way how we expire and rotate access token while not needing to re-authenticate again. And so as we are getting close to the end of the webinar, I will try to briefly talk about the scopes. And these are actually permissions associated with the token. So when you are sending request for the token, you are sending request for the scopes. So your application can list, okay, these are the scopes that I'm requesting. It's up to the server to decide, yeah, you will get these scopes within your token or not, because you don't have permissions for this. And the very important thing about these scopes, these are not actually user permissions. You can treat them to some extent that way, but what are the sorry, I was reading the Daniel's question. So ID token has more info. Okay, so there is no actually difference in the security when it comes to these, but ID token reveals more information, as you said. So access token should be used for accessing data, and ID token should be used to get the user get the user information. So so you can, if you need user information, you have to use ID token, and they are often, if you are using OpenID, if you need that information, you need ID token. So it's not less secure. It's just about revealing it's just about revealing user information, because these information are not encrypted, and you need to be careful what kind of information you are putting into the ID token. So that's the only thing. Unless I'm missing something, but I don't think they are less secure in that sense, that you shouldn't that they cannot be that they shouldn't be used. They have to be used if you are using OAuth as per specification. Does that answer your question or? Okay, thanks. As for the scopes, these are actually permissions for your application. You can think about these guardrails, what your APIs, what you can do with this access token, and this is a little bit tricky. So are not these scopes are not defined in specification, so there is no right way or wrong way to define them. So if you look into some of these examples, you see the AWS Cognito sign-in user admin. So this means actually, if you have this scope within your token, that you can make admin requests to your Cognito. So you can actually do stuff on the service itself. So you need to be really careful when it comes to scopes, how you are defining them, and actually on the server you need to implement what can you do with those. And if you are using third party authorization server, you better be informed what those scopes meaning, because you might unintentionally allow your users to change actually setup of your authorization server, which is one of the concerns when it comes to Cognito and to this scope. So there are reserved scopes and the custom scopes. So when you are using third-party services, there are the reserved scopes that you cannot define, because they are reserved for the using the internal APIs, but you can define your custom scopes, and the scopes should be used only to limit your application. What can it do? So if you limit the scope to, let's look into this example for the GitHub. There is a repo status. You can, if this scope is defined, your API should only read status of the repo. And there is as you can see here, GitHub is using a clever way to group scopes, like admin permissions, and it says admin repo hook, and it can be more admin permissions that they are allowed with the given token. So you can define multiple scopes within your token. But the problem here is, as I said at the very beginning, is that the token can become very large, so in size, and that can prevent you to make requests, because if you reach 8 kilobytes, then you will most probably have an issue. So if you need to have fine-grained permissions for your users, and this is something that I will use as a final thoughts in the webinar, and to close this scopes topic. I will share my screen and show you options that you have for your fine-grained permissions. So when your scopes, when the scopes are not enough, when you want your user to, when you are limited with the scopes, you are limiting access to the resources. But if you need fine-grained permissions for your business logic, what your user can do within the application, then you will need to implement that by yourself. So for that purpose, you have Amazon verified permissions, and I would highly recommend you to look into this. And this is using Cedar language. to define these permissions. You should also look into those. And I mentioned all these links into the references because this is a completely different topic. If there's interest in the future, we might have a webinar that covers Amazon verified permissions and the Cedar language. And as an alternative, if you are OAuth2 fan, there is something that is in developer preview. So Amazon verified permissions are actually generally available, so you can safely use those in the production. And at this trainment, you can find a really nice talk about real world use case. You can find case study, uh, how they are used, and how they helped company to save money and time. And as it comes to Okta and OAuth0, they have their fine-grained authorization, and this is a pretty new service, and this is still in a developer preview. So if you need alternative, you can look also into this. But Amazon verified permissions are actually generally available, so I would recommend you to go uh, that way. So that being said, I tried to answer all your questions during the webinar, and if you have additional questions right now, I'm ready to answer. Otherwise, we can ask Jonathan to join and sign us off, because he's the guy in our backstage who never gets enough attention from us.
I think I get plenty of attention. Don't encourage me. I feel like pretty soon will be a webinar, which is going to be me and being like, "Hey guys."
No,
There's nothing going on today.
we are really grateful to Jonathan, because he's the guy who is doing all the heavy lifting in
Oh
the
no.
in the background. We just talk.
Yeah, if I do a good enough job, they say they'll let me leave this dark room. But I don't know if I've done a good enough job yet. Hopefully, people, they stream in and say that I did a good enough job, so I can finally see the sun again. But Almir, you did an amazing job. If there's any questions or anything like that as we wrap up, I'll let that come in. But yeah, like Almir was saying, this is part 2 of a 3-part series. So I think coming up on February 29th. We'll have that webinar sign up page up pretty soon, but you'll be able to finish off the series with us. And of course, this and part 1 will be on YouTube, so you should be able to catch up on the entirety of it if you were, lucky enough to join us for part 1 and part 2 today. That's awesome. If not 1 or part 2, you can always catch up and get ready for part 3 with us. That will be coming up pretty soon. But yeah, Almir, I'll let you have the final word, and I'll give us or I'll sign us off if we're all good.
Oh, thank you, Jonathan. Thanks everyone for watching. That's all for now.
Perfect. Well, thank you guys. We'll see you soon. Till the next time. Bye bye.